Hello, we are back in Mrs. Engel's living room to do our basic stoichiometry review video. In this, we always must make sure that we have a balanced reaction, right? What I have right now for you, C3H6 plus O2 yields CO2 plus H2O is a skeleton equation. So the first thing we're going to do is balance it. And we start off with 3 carbon, put 3 here, 6 hydrogen, 3 over here, and here we get to the situation where we have 9 oxygen. This is a great example of an odd-even problem. So let's erase. And you want to double your odd. We had 3, make that 6, causing us to have 12 hydrogen, 6 carbon, and 9 oxygen. Now the problem that we're going to do will be how many liters of CO2 gas. Remember, liters must always be used with a gas. You cannot use it with a solid or a liquid. Form if 120 grams C3H6 reacted excess oxygen. Now this is a basic stoich. You're giving a reactant and a product. You could be given from a product's perspective back to a reactant, but you are given one of each. This is not an example of limiting reagents because we are not including quantities for both of our reactants. Starting material, 120 grams of C3H6. As always, right compound, we need to convert from grams. You have to get it into a mole because our balanced equation is based on the mole. Multiplied by the molar conversion. For every 1 mole of C3H6, we have 30 grams. If you are confused about this, remember to go to your periodic table, look up carbon and hydrogen's atomic mass, multiply by their subscripts, add them together. This is going to give us 4 moles. Let's C3H6, but I'm interested in CO2. We need to look at our mole ratio. For every 2 C3H6, 6 CO2 form, which is 3 times the amount. So take your 4.0 and multiply it by a ratio of 3, or a proportion of 3. That will give you 12 moles of CO2. But that's not finishing up the problem. The problem is liters of CO2. I'm at moles. I now need to convert to liters. Again, for every 1 mole of CO2, it's 22.4 liters, multiplying by Avogadro's hypothesis value of 22.4 liters for every 1 mole. Your final answer here, (269 liters of CO2. Now for every basic stoichiometry, there is always a quantity that is given and a question, something you're trying to find. Always, always, always balanced equation, mole ratio. So it doesn't matter where I begin at grams, liters, molecules, always convert to moles. For moles, molar proportion. This is the step that makes it stoichiometry, when you're converting from one substance to another via balanced equation. And then finally, I can take moles and go to liters, I can go to grams, I can go to molecules. Doesn't really matter. I'm always going to divide to get to moles. I'm going to multiply by a proportion. That proportion can be a fraction. The opposite had been true. If it had been 2 to 6, I would have divided by 3 and not multiplied by it. And then I'm going to multiply by my next molar conversion. And that is how we do basic stoichiometry. Until next time, this is Mrs. Engel.